Okay, so on worksheet, this is 10A. We're going to talk about solving absolute value equations and inequalities. Connects quite well with the previous lesson. That's why we skip around. If you notice, we skip around in chapters, etc. It just doesn't mean we're in chapter 1. You are aware of what absolute value means. It means the distance from 0. We already went over that. Always positive or 0. The distance from 0 to 4 is 4. The distance from -4 to 0 is also 4. Okay, so what's inside the absolute value bar can be a positive amount or a negative amount. So there are two solutions to the absolute value of x is 5 or -5. So with that in mind, if you have an equation, you're going to solve it by dropping the absolute value bars and saying that 2x minus 5 is equal to 9 or -9. So you have the two answers. We got add 5 to both sides. Dividing by 2 gives us the first answer of 7. Oops, doesn't look much like a 7, does it? Okay. The second setup, setting it that what's in the bars. Remember, never, ever, ever change what's in here. You change the number not inside the bars. So adding 5 to both sides on this one gives you -4, and then dividing by 2 gives you -2. So the two solutions are 7 and -2. For inequalities, that's when you have a less than or greater than or equal to or less than or equal to. You must flip the sign for a negative number, which meant the other day when we talked about it, if we multiplied or divide both sides by a negative, then we had to flip or reverse the symbol. All right, so much like that, if you remember, if you're going to change the 11 to a -11, you have to flip the symbol. Okay, so our two equations or inequalities, we should say, that we need to solve for solving this original inequality, you write two separate inequalities. One, 2x plus 7, don't ever change what's inside of the absolute value bars, is less than 11. We would subtract 7 from both sides and divide by 2, and that would give us x is less than 2. The other part, by the way, this is a less than. That's going to be your and equation, which means where do the two solutions overlap. The second part of it, you set 2x plus 7 greater than -11. We would subtract 7 from both sides, giving us -18. Dividing by 2 gives us x is greater than -9. So it's and. So it says x is less than 2 and it's bigger than -9. So I hate these number lines just because I don't even know if I could fit them. Are there enough marks to do -9 all the way to 2? All right, I don't feel like using it. So I'm going to make my own, and I'm just going to put a -9 on there and a 2. And then I'm going to say, all right, they're 11 apart, so I just didn't see if there was 11 marks there. I believe there actually are. This is an and, which would be an in between. So what it's saying is it's less than 2, so it doesn't include, excuse me, my pen's stuck, doesn't include the 2 or the -9, but it's everything that's bigger than -9 but less than 2. So that'd be in between. The interval notation, very similar, -9 to 2. Now this one has the absolute value of something is greater than a number. Greater than, those situations are your ors. Okay, so you write the two separate inequalities. 3x minus 2 is greater than or equal to 8, or 3x minus 2 is less than or equal to -8. Remember to flip the symbol when you change the sign. We would add 2, and that gives us 10, and then we would divide by 3, so we'd get x is greater than or equal to 10/3. The other inequality, 3 times x is less than or equal to, adding 2 gives us -6, dividing by 3, x is less than or equal to -2. Now this is an or, so it's greater than 10/3, which is about 3 1/3, or it's less than -2. Well, I'll just pick a place for -2. I'll use this thing. It's including that -2, but everything's smaller, or means to put two things together. So we've got from -2 down, and then 10/3, say that's -2 to be -1. This would be 0, 1, 2, 3, and 4. 10/3 is 3 1/3. So it's actually a little higher than 3. On up. And in interval notation, this is from negative infinity up to -2 inclusive of the -2, but you never always soft bracket on infinity. You union that with 10/3 inclusive to infinity. Okay, man, we just learned our interval notation on Friday, right? Okay. All right, all good? Anybody need this still? All right, moving. Okay, so here we go. Time to set it up ourselves. So we have a greater than. That will be an or. So 4 times x plus 10 is greater than 2, or 4 times x plus 10, flip the sign, is less than -2. 4 times x, subtracting 10 from both sides gives us -8. Dividing by 4 gives us x is greater than -2. Or subtracting 10, 4 times x is less than -12. Dividing by 4, x is less than -3. So greater than -2 or less than -3. That's not very, there's only one unit, 1 separating -2 and -3. So if I put -3 there and -2 here, x being greater than -2 would not include that -2, but shaded above. Or it's smaller than -3, which would be not including the -3, shaded on down. Now, you need to write your inequalities left to right when your solution sets. So interval notation needs to start with the leftmost portion, okay? It needs to go from left to right like you read. So that would be -infinity to -3, soft bracket on both, union with -2 to infinity. Okay. The next one is also an or. What I'm looking at is the fact that there's a greater than symbol there. I'm just going to highlight it, but I guess it really doesn't matter. It's another or. So drop the absolute value bars and just rewrite it. 2x plus 3 is greater than or equal to 11, or 2x plus 3 is less than or equal to -11. Subtract 3. Divide by 2, we get x is greater than or equal to 4. The other part, subtract 3, we get -14. Divide by 2, x is less than or equal to -7. Okay, so if x is greater than or equal to 4, or less than or equal to -7, I don't like that number line. I'm just going to make my own. -7 shaded left and including the -7, and then 4 and up including the 4. Interval notation, -infinity to -7 inclusive, hard bracket, soft bracket on -infinity, union 4 to infinity. Okay, I'd like you to try the next 3, and then we'll check them, please. Okay, should be done with that first one. I guess obviously you can pause if you're at home looking at the video, but you should have a -2 and a +3 for the first answer, and that's it. That would, if you were to graph that, that's just 2 answers, period, 2 dots. Okay, go for the next couple. You should have these 2 equations, and you should have gotten x is less than or equal to 15/2 and bigger than or equal to -3. So if you were to make this, I don't think it fits, bless you, on the number line very nicely. But 15/2 is 7.5. So as long as you have -3 inclusive up to 15/2 inclusive, it would be in between. shaded in the middle. And then the interval notation, -3 to 15 halves with hard brackets. Okay, how many of you are done with number 3 also? Okay, I'll give a second here. This one should be an or. Got a lot of turning around and symbols on that one. Should have x is less than -1 or x is greater than 11. And again, I'm making my own because you can't space it properly on that. So it should be two tails. And that's what we're going to do next is generalize. So the interval should be -∞ to -1, soft bracket on both, and then 11 to infinity, soft bracket on them. All right, for the generalization part, an absolute value less than or equal to statement with positive number means 2 inequalities with and between. The graphs are going to look something like that. But an absolute value with a greater than or equal to statement means 2 inequalities that are going to be tails. You always need to isolate your absolute value before solving the equation or inequality. All right, so a few more examples. You want to subtract 2 first. Then you can drop the absolute value bars and write your 2 separate equations for this particular one. We're going to add 3 to both sides, and one answer is 6, the other would be 0. Number 5, first step, add 3. Don't drop your absolute value bars at all until you've got the absolute value isolated. Then you can drop it and write your 2 equations. Subtracting 1 and changing the sign or dividing both sides by negative would give you m is -3 for one of your answers here. The next one, you would subtract 1 and get -5. Change the sign, m would be +5. This one is an inequality. It has a less than symbol. It's an and. But first, subtract 2. Still have my absolute value bars. I'm subtracting 2 to get 8 on the right. Now I can drop the bars. 6 minus 2 times r is less than 8. 6 minus 2 times r is greater than -8. Subtract 6. Get x -2r is less than 2. Divide by -2, and don't forget, flip the sign. R is greater than -1. On the next part, subtracting 2 gives you -2 times r is greater than -14. Divide by -2, flip the sign. R is less than +7. So it's greater than -1, which is here. What is going to happen on this one? Greater than -1 be all of that. Less than 7 would be from here on down. And it's an up, it was an and, right? So where should I erase? Greater than -1, less than 7, it's going to be this piece right in between there. So if you ever did that, and you just go and erase, because it's the overlap of the 2 graphs. Now, one reason I did that, there's a time when you're going to get the entire number line. It can happen. Okay, if you're just going where they overlap, then it's just this piece. If it happened to be the entire number line, because it was an or instead of an and, say this one had been an or, then you would have had any solution works. So I want you to realize that there are those, that can happen, and it will in the homework. Okay, so let's try number 7. This one is one of those. This one is an or. I was hoping to have an example of that occurring. All right, so since it's an or, we're going to be putting together two solutions. So we're going to do 2x plus 3 is greater than or equal to negative 13, or 2x plus 3 is less than or equal to positive 13. You're supposed to change the sign and flip the symbol. If you solve this guy, you subtract 3 from both sides, you get negative 16, and then you divide by 2, you get x is greater than or equal to negative 8. Now that's going to be from negative 8 on up. Well, now I'm going to do the other part. So I'm going to subtract 3. I get 2 times x is less than or equal to 10. Divide by 2. 2 times that would be x is less than or equal to 5. So that would be from 5 on down. So when I put these together, because it's an or, I get the whole number line. So that would be another way to say it is all real numbers or any solution. Now let's think about why that would be the case for this situation. When you do the absolute value, don't you always get a positive? So it makes sense for this problem that anytime you get a positive number, it's going to be bigger than a negative one. Okay? So you could have actually guessed that it was any real number for this one. Can this ever be less than negative 2? If it's positive, can it ever be less than a negative? No. Okay, this one is an and I'll show you how it works. Say you didn't notice that right away. 5 times x plus 2 is less than or equal to negative 2. 5 times x plus 2 is greater than or equal to positive 2 would be your equations. Subtracting 2 will give you negative 4. Dividing by 5 would give you negative 4/5. Well, I'm not going to graph it yet. This one, subtracting 2 would give you 0, and dividing by 5 would give you x is greater than or equal to 0. Well, if x is, and it's an and, how can x be bigger than, that would be from 0 on up. This one would be from negative, what's that? Just a little bit more than, a little bit under here, right? It's just a little less than 0, not quite negative 1. So that would be from there going that way. Where do they overlap? They don't. They don't overlap. So there is no overlap. And if it's an and problem, then there's no overlap, then there was no solution. Okay, I hope that explains why it should come out the way it is. All right, then we have a book problem. I want to show you how to do a problem that is in your book. And I'm going to kind of try to have you think about what I'm writing. I want to write an absolute value inequality. Okay, based on the picture, is this an and or an or? Okay, since it's between two numbers, it's an and, which means it's going to be less than. And then you see how these are shaded at the ends? There's a dot that's solid. That would mean it's including. So it'd be less than and equal to. All right, so I'm trying to write one of these, and it's going to say less than or equal to. And then I'm going to have a number over here. So let's think about how we might figure this out. Absolute value means the distance from 0. But we've been adding stuff on to this situation. It's not just the absolute value of x. So where would we maybe need to figure out is between here? What would it be called to find the middle. We want them to be an equal distance from -4 and 6. What do I need to locate? You know what it's called when you find the, okay, all right, midpoint. That's what I'm trying to get. -4 plus 6 divided by 2 will give you the midpoint. So I took the endpoints, and I'm going to find the midpoint, which we're learning in geometry right now. -4 plus 6 is 2. 2 divided by 2 is 1. Okay, I just found the midpoint. That's 1. All right, that's something we need, okay? Now, we also need to know how far it is to get to here. Or it's the same distance to get to here. And what is that distance? 5. Okay, 5 that way, 5 that way. So 5's got to be something that has to do with our answer. All right, so we've got x and 1. Now we're going to guess. All right, from this equation, what do we need to get from when we solve it? You need to get a 6 and a -4. Okay, so maybe it's, well, what needs to go here is either 5 or 1, and what needs to go here is 5 or 1. So we got a 50-50 chance probably of doing it right. Okay, so what if I put 5 here and I put 1 there? How would I get a 6? I would need to do what to get 6? I need to add, right? To get -4. So if I put 1 there, I could add 1 and I'll get that 6, which means I'd want that to be minus. But if I make this be -5, remember how you'd write two equations when you solve this? If it was -5 and I added 1, would I get the other end? Okay, so we've got it right. We've got it right. All right, so here's the deal. What you do is, and I just tried to tell you how I figured out a way to explain this to you, okay? The way I thought about how to explain this to you was how I thought about it was like, all right, let's make a strategy. Let's figure it out by playing around with the numbers. If we flip-flop these numbers and we did, would this work? If I add 5, I'd get 6. But if I change that to -1 and I add 5, will I get my -4? Hold on. -1 plus 5 would be +4. So that's why it didn't work this way. So here's the deal. Now, from just investigation, what do we put right here? This would be the midpoint. Got it? To write one of these, you can do it every time. It's always going to be minus your midpoint. So if your midpoint's negative, then we're going to have what here? We'll have plus, all right? And over here, this is the distance on the left and the right to the other endpoints, okay? Distance to endpoints. Now, let's try another one. And I think then it'll start to make sense to you. There's not like a formula. I mean, it kind of is in a way. I guess we're kind of making a formula for it. All right, so this one's an in-between too. So this one's also an and. All right, so it's going to be a less than. It has curved bars on the ends. Let's say we know where these are because it's trying to be ambiguous. I believe that that's at -6, right? And this is at 9. Okay, -6 to 9. All right, let's find the midpoint. -6 plus 9 divided by 2 is 3/2. Okay, that's our midpoint. So it's going to be the absolute value of x minus 3/2. And then we know it's less than and doesn't include. Now what else do we got to figure out? We found 3/2, which is 1.5. We need to know how far it is from there to there and there. Okay. All right, so what that distance is, how can you get the distance from there to there? subtract them. Negative 6 minus 9 divided, isn't it negative 15? Oh, that doesn't. Yeah, it's 15 halves, isn't it? 15 halves from here to here, right? Yeah, so you just put the numbers together. Actually, I subtracted them, and then it's either left 15 halves or right 15 halves. So let's see if this works. Right, that works because you get, if you add 3 halves, you get 18 halves, which is 9. Okay, if you change that to negative 15 halves and you add 3 halves, you will get the other end. This one's different. This one's an or. Okay, this one's an or. So where do we need to look? In between. Okay, we still want to do the same thing we did over here between the numbers, between the ends, but we're just going to write a greater than. All right, it's going to be greater than or equal to. All right, now let's figure out what goes in here. All right, where's the middle? Well, it goes from 0 to negative 8. Negative 8 plus 0 divided by 2 is negative 4. There's your midpoint. Okay, it's a negative, so since we would normally subtract a negative, well, minus negative 4, that's going to give us x plus 4 in there. Okay, and then how far is it here to here? 4 units. Okay, check it out. If we subtract 4, do we get 0? Yes. If we change that to negative 4 and subtract 4, do we get negative 8? Yeah, we're good. All right, that would be the equation for this one. All right, your assignment is on 11A. You guys time to work? Let's get busy.